Welcome back to my channel Statistics Made Simple, and I am Savita Valsang. In this video, I'll explain the Maximin Minimax principle to solve a two-person zero-sum game, which is an important phi marker. There are two methods of solving a two-person zero-sum game. In this video, I'll be explaining the first one, which is the Maximin Minimax principle. There are three steps which are involved under this method. First is the minimum payoff in each row of the payoff matrix is circled. Then maximum of the minima is found, which is the maximin. Second step is maximum payoff in each column of the payoff matrix is boxed. Then minimum of the maxima is found, which is the minimax. The third step is if any payoff has both the circle and the box, that is maximin is equal to minimax, then that payoff is the value of the game and the corresponding position is the saddle point. These are very important steps and the method is extremely simple to understand and solve. Problem 1. Two players A and B play a game of tossing coins. If the outcomes of the coins match, then A gets rupees 5 from B, and if the outcomes of the coins don't match, B gets rupees 10 from A. Write the payoff matrix for player A and solve the game using the Maximin Minimax principle. So under solution, let us first learn how to write the payoff matrix for player A. So when we write the payoff matrix for player A will have the strategies denoted in terms of rows and player B's strategies are denoted in terms of columns. Now because both the players A and B are playing a game of tossing coins, we know that a coin will have two possible outcomes, which are heads and tails. So here in the payoff matrix for player A, first write player A and he has two strategies which are denoted by A1 and A2, which are corresponding to head and tail. Similarly, player B will have two strategies denoted by B1 and B2, and in this case B1 is heads and B2 is tails. Now they have mentioned that if the outcomes of the coins match, that means if both the players' strategies are heads or if both the players' strategies are tails, then A gets rupees 5 from B. So because A is getting an amount, it will be positive. And if the outcomes of the coins don't match, that means if you see if player A has the strategy A1 as head and player B has the strategy B2 as tail, then what is happening is B gets rupees 10 from A, or in other words B is losing 10 rupees, so it will be minus 10. Similarly, if player A's strategy is A2, which is tail, and player B's strategy is B1, which is head. Again, in this case, B gets rupees 10 from A, or in other words, it means that A is losing 10 rupees. So the payoff matrix will look as shown in this slide. Corresponding to A1, B1, write the value 5 because the outcomes are matching, and for H and T, that is A1, B2, it will be minus 10 because the outcomes of the coins don't match. Similarly for A2, B1, again the outcomes don't match and so the payoff will be minus 10, and for A2, B2, that is both the strategies are showing tails. In this case, A gets rupees 5, so you write 5. So once you write the payoff matrix for player A, Next, we have to solve the game using Maximin Minimax principle. So in the Maximin Minimax principle, what you have to do is form a minimum column outside the matrix and form a maximum row below the matrix. So corresponding to the first row, that is strategy A1, you have to find out the minimum value. So the minimum value is minus 10, which is circled in pink color, and then you write it under the minimum column as minus 10. Similarly, corresponding to the next row, that is for strategy A2, the minimum value is minus 10, circle it and then write the value minus 10. The next step is to find out the maximum payoff in each of the columns. So corresponding to B1 strategy, the maximum value is 5. So you put a box around it, and here I have used purple color, and then corresponding to maximum, write the value 5. Similarly, corresponding to the strategy B2, in that particular column, the maximum value is 5. Put a box around it and write the value 5. So once you write the payoff matrix for player A, what you have to do is, in the next step, find the minimum value in each row and circle it and write it under the minimum column. And then the next step is to find out the maximum value in each column, and you put a box around it and you write it in the maximum row. Now let us find out Maximin, which is equal to maximum of the minimum values, which is equal to maximum of, within flower brackets, write the two minimum values, which are minus 10 and minus 10. So the maximum of these two values will be minus 10. Similarly, let us find out minimax. Minimax is nothing but minimum of the maximum values, which is minimum of 5, 5, which is equal to 5. Now we see that maximin is not equal to minimax, hence there is no saddle point and no value for the game. Problem 2. Players A and B play a game in which each player has 3 coins, 1 rupee, 5 rupees and 10 rupees. Each of them select a coin without the knowledge of the other. If the sum of the coins is an even number, A wins B's coin, otherwise B wins A's coin. Write the payoff matrix of A and solve using Maximin Minimax principle. I will now explain how to write the payoff matrix of player A. In the first table, in the first column, I have player A. The strategies are 1 rupee. Again, you have 1 rupee, 5 rupees, 5 rupees, and 10 rupees. Player B's strategies are highlighted in red color, which are 1 rupee, 5 rupees, 1 rupee, 5 rupees, and 10 rupees. I have written it in this order because the sum should be even. So in the third column, we have, when sum is even, A wins an amount of B's. So when I add the first two column values, the sum is equal to 2 in the first row. In the next row, when I add 1 and 5, the sum is equal to 6. Similarly, when I add 5 plus 1, sum is 6. And for 5 plus 5, the sum is 10. And 10 plus 10, the sum is equal to 20. So we observe that these sums, 2, 6, 10 and 20, are even. Now whenever the sum is even, A wins an amount of B's. That means in the first case, when the sum is equal to 2, A will win B's 1 rupee. Okay. Similarly, when the sum is equal to 6, A wins B's amount, which is 5 rupees. Similarly, in the next row, I have 1 rupee, 10 rupees and 10 rupees. Now, in the next table, in the first column, I have player A's strategies as 1 rupee, 5 rupees, 10 rupees, and 10 rupees. And player B's strategies are 10 rupees, 10 rupees, 1 rupee, and 5 rupees. So now we are considering the case of when the sum is odd. So when the sum is odd, B wins an amount of A's, or in other words, it means that A loses its amount. So corresponding to the first row, when I add 1 and 10, the sum is 11. When I add 5 plus 10, the sum is 15. When I add 10 and 1, the sum is 11. And 10 and 5, the sum is 15. So 11, 15 are odd values. So in this case, what happens? B wins an amount of A's, or A loses its amount. So when the sum is 11, A is going to lose his amount, that is 1 rupee. So it will be minus 1. Similarly, when the sum is 15, A will lose 5 rupees. So it will be minus 5. When sum is 11, A will lose 10 rupees. So minus 10. And when the sum is 15, A will again lose 10 rupees. So it is minus 10. So this table is only for your understanding. It's not required in the exam. In the next slide, we will learn to write the payoff matrix of player A. So under solution, first write the payoff matrix for player A. So the rows will have player A with his strategies, and player B will have the columns with his strategies. Now, because there are three different denominations, both the players will have three strategies. So corresponding to player A, you have A1, and within brackets you can write the amount, which is 1 rupee. Then you have A2, and the amount is 5 rupees, and A3 is 10 rupees. Similarly, for player B, B1 will be 1 rupee, B2 will be 5 rupees, and B3 is 10 rupees. So now from the previous slides, we have the payoffs for each pair of strategies. So when both the coins show 1, that is when the sum is equal to 2, then the payoff is 1. Okay, so corresponding to the strategy A1, the payoffs are 1, 5 and minus 1, and corresponding to A2, the payoffs are 1, 5 and minus 5, and corresponding to A3, the payoffs are minus 10, minus 10 and 10. So this is the payoff matrix for player A. Next, we have to solve the game using the Maximin Minimax principle. So the next step is to form the minimum column and the maximum row. So in each of the rows, first we need to find out the minimum value. So the minimum of 1, 5 and minus 1 is minus 1. So minus 1 is circled in pink color. In the second row, for the payoffs 1, 5 and minus 5, the minimum value is minus 5, which is circled, and then it is written under the minimum column. Similarly, in the third row, the minimum of the payoffs minus 10, minus 10 and 10 should be found, and the minimum value is minus 10. So both the minus 10 values are circled, and then write the value minus 10 under the minimum column. Next is to find out the maximum value in each of the columns. So in the first column, that means corresponding to B1, we have to find out the maximum of 1, 1 and minus 10. So the maximum value is 1. Both the ones are boxed in purple color, and then write the value 1. Corresponding to the second column, we have to find out the maximum value among 5, 5 and minus 10. So the maximum value is 5. Both the 5's are boxed, and then the value 5 is written corresponding to the maximum row. Similarly, in the third column, for the payoffs minus 1, minus 5 and 10, the maximum value is 10. So put a box around 10 and then write the value 10. The next step is to find out Maximin. So Maximin is maximum of the minimum values, which is maximum of -1, -5 and -10. So which is equal to -1. Similarly, find out minimax, which is minimum of the maximum values, which is equal to minimum of 1, 5 and 10, which is equal to 1. Therefore, we see that maximin is not equal to minimax, hence there is no saddle point and no value for the game. Problem 3. Solve the game using Maximin Minimax principle. Is the game fair? So we have a matrix which is given, that is a payoff matrix is given for two companies, company X and company Y. So for company X, the strategies are A, B, C, D, and for company Y, there are three strategies P, Q, and R. So the payoff matrix has the values 3, -1, 3, 2, -1, 2, -1, 0, 0, 2, 0, and 4. So let's start with the solution. Consider the payoff matrix for company X. So first write down the payoff matrix as given in the problem. Now the next step is we need to find out the minimum payoff in each of the rows and maximum payoff in each of the columns. So form the minimum column and the maximum row. So corresponding to the first row, that is company X has the strategy A, the values in the payoffs are 3, -1 and 3. The minimum value is -1, so put a circle around it and then write the minimum value which is -1. For the second row, the payoffs are 2, -1 and 2 and the minimum value is -1, so circle it and write it in the minimum column -1. In a third row, among -1, 0 and 0, the minimum value is -1, circle it and write it in the last column, that is -1. And for the last row, the payoffs are 2, 0 and 4 and the minimum value is 0, so circle it in pink color as I have done and write the value 0. Next, find out the maximum in the first column, that is company Y's strategy P. So the payoffs are 3, 2, -1 and 2. The maximum value is 3. So put a box around it and write the maximum value as 3. Corresponding to the strategy Q, the payoffs are -1, -1, 0, 0. So the maximum value here is 0. So put a box around both the zeros like I have done in purple color and then write the maximum value 0. Then corresponding to the strategy R, the payoffs are 3, 2, 0 and 4. The maximum here is 4. So put a box around 4 and write the value 4. Now consider Maximin, which is equal to maximum of the minimum values, which is maximum of -1, -1, -1 and 0, which is equal to 0. And minimax is minimum of the maximum values, which is minimum of 3, 0 and 4, which is equal to 0. Here we see that maximin is equal to minimax is equal to 0. The value of the game is 0 and the game is fair. Now you can find the saddle point in the payoff matrix. So whichever payoff has both the circle and the box, that is the point where the saddle point exists, or that's the position where the saddle point exists. So don't forget to write the best strategy for company X is D and the best strategy for company Y is Q. So for any problem in game theory, when you are asked to solve the game, we have to find out what is the value of the game. And if the value of the game exists, we write the value. And if it doesn't exist, we say that there's no value of the game. And sometimes they'll ask us to mention whether the game is fair. So whenever the value of the game is 0, only then the game is fair. And irrespective of whether they ask us to write the best strategies for both the players or for both the companies, it is better to mention what the best strategies are. So continuing with problem 4 now. In a rectangular game, if the saddle point exists and maximin is equal to 4, what is the value of minimax? So in this problem, they have mentioned that the saddle point exists. So when the saddle point exists, you should remember that maximin will always be equal to minimax. So therefore, the answer is minimax is also equal to 4. Problem 5. In a two-person zero-sum game, if the gain of one player is 3, what is the loss of the other player? So solution is very simple. The loss of the other player is minus 3. Problem 6. If the value of a game is minus 6, what is the value of the game called as? Solution. The game is not a fair game. That's what we can say, as the value of the game is not equal to 0. The Maximin Minimax principle is very simple and you can easily score 5 marks if a question is asked based on it. So practice the problems. Thank you all for watching and look out for my next video where I'll explain the next method, which is called as the dominance principle, to solve a two-person zero-sum game.